All right, first up is the circumcenter. How can I use constructions to find the circumcenter in this triangle? Well, first, I need your help, right? I'm not going to teach you. I need your help. Talk to me about circumcenter right now. Anything coming to mind when you hear the word circumcenter? Because I want to write it down. And then we'll talk about how to use the compass. All right, so circumcenter. Shoo, Max, what's coming to mind when you hear circumcenter?
The point where all perpendicular bisectors.
I love it. Perpendicular bisectors meet. Okay, we'll start there. Perpendicular bisectors meet. Next, because this is how we're going to check. This is how we're going to check if we found the correct circumcenter or it's in the correct spot. What do you know about the circumcenter? What's so special about it? The fact. You guys wrote it down in your chart yesterday. I know where that's where the perpendicular bisectors meet, but it's also, what about the circumcenter? Choom, Sakura, what else do you know about it? From the, yep, and that's how we're going to check it. Because it should be equidistant from the vertices. Good work, good work. All right, perfect. I think we have enough knowledge now to construct the circumcenter because I was just told by Max that that's where Max, it was you, where the perpendicular bisectors meet. So now I got to remember, I've shown you that construction. Scavenger hunt time. Let's watch the video again. Not me, but you. Go ahead, watch the video. How do you do a perpendicular bisector? And then go ahead and do it on one of the sides. This is much better than me standing. Step one, you do this. Step two, you see it on your own now being done. Yep. So take a side right now of triangle ABC and let me see you do a perpendicular bisector.
I don't know better. No, I just like.
I do it on a line segment on the video, but hey, a side is a line segment. So take one of the sides of triangle ABC and please construct your first perpendicular bisector.
Now we're going to.
Oh, this one, Miss Linehan must have did this one. You don't have to do the same side I'm doing, just do a perpendicular bisector for one of the sides. Good job, you guys even put markings on it. I love it. I love it. When you think you're satisfied and confident enough, go ahead and make a second one, right? Because circumcenters were all three intersect, but do not go on to a third one. Right? Once you're confident in your first, go ahead and do a second one, but do not do a third one. I want to talk to you guys about something. Again, I have not taught anything yet today. You guys are filling in everything for me. Just do 2, just do 2. Put your compass on a point, open it up more than half the distance, swing a big arc, go to the other point, swing the same arc so you have 2 points of intersection. I want to remind you guys of the definition of a circumcenter again, because some of you guys are making tiny perpendicular bisectors. Remember, circumcenter, it's where the perpendicular bisectors intersect, right? Intersect. So some of you guys may need to make your perpendicular bisectors a little longer. They have to, right? I got to find where these things are going to intersect. All right, I got to find where they're going to intersect. So you may need to take your straight edge and make it a little longer. I purposely did not have you do the third one because I wanted to have a quick discussion. The circumcenter is where all 3 perpendicular bisectors intersect. Is it necessary for us to go and do the third? No, because we all know all 3 are going to always intersect at the same point. So right now, when I have my 2 already up there, there's only one option. There's only one spot the third one could intersect if they're all going to intersect at the same point. So you do not need to do all 3. You only need to do 2 of them. Do we see where the circumcenter will be? Put a point there, please. Put a point where the circumcenter is going to be. We do not need to do a third perpendicular bisector. We already know where it's going to intersect. We can't do this for all of these, but we can do it for the circumcenter. Sakura told us it was equidistant from the vertices. Well, it better be. Grab your compass. Put your compass point on where you think your circumcenter is. And then put your other point on a vertice. Open up your compass to that distance. Now move your compass to another vertice while still staying on the circumcenter. Did you have to open up or close your compass at all? Landed perfectly, didn't it? How beautiful is that? Oh, you want to try the third one? Go ahead. Yeah. It is equidistant from the vertices, so that definitely has to be my circumcenter. Also, because you guys are in what class? Yep. I don't think you guys, I think you might run off your page if you try to do it here, but I'll do it up here on the board. I haven't mentioned this yet because I didn't want to fill your brain with a whole bunch of mush and facts like I have already. And you don't really need to know this for any test or quiz, but that circumcenter is also the center of a circle. That didn't work. I can draw on the outs, I can circumscribe around the triangle. Okay, where mine's off a little bit, but if you tried it on yours, I bet you all the vertices would land on that circle. Okay, does yours run off the paper if you do try that? Anybody want to try? Give it a try. Put your compass point on the circumcenter, pencil on a vertice, and give it a swirl. Will it go off the paper, or does it fit?
It goes off.
Yeah, we'll go off the paper, but you guys can see it start hitting. I can see Assad here start hitting your vertices, right? Look at that, it's beautiful. Yep, it's the center of a circle. I can circumscribe. Okay, all good. Circumcenter. Didn't really have to tell you much. You just had to review the video. Next up, how can I find the in-center of a triangle? In-center. All right, well, talk to me, kids. In center, what are we thinking? In center, Michael, what are you thinking in center?
It's like equidistant from all sides.
Okay, but I like good. Equidistant from the sides. All right, one more fact I'm looking for here. Word association, in center, and Natalie?
The angle bisectors.
Angle by, there it is, where the angle bisectors intersect. So it looks like we're going to have to bisect the angles, huh? Scavenger hunt time. Go ahead. How do I do an angle bisector now? All right, take an angle and bisect it for me.
Don't they like have to form a 90-degree angle on the sides?
That's another word. Oh, with the, yes, they do. That's why we're not going to be able to check it. Or when it's the sides, yeah. In center, let's see it. Angle bisectors now. Angle bisectors. Should be 3 small arcs. You make 1 arc across your angle, and then go from each point of intersection, make 2 more that intersect. Once you're confident in one, go ahead, bisect another one. I like it. I like it. Talking to each other. If you have issues, talk to each other.
Yeah, and then it intersects it again for the other. Yeah, exactly. So you just drop a line through the intersection and
I don't like that. And same discussion we had for circumcenter. Do I need the third? Nope. I already know where it's going to intersect if I know where the first 2 intersect. That's your call. Yeah. Yeah. And like on the first arc, I've seen kids, because they don't like that huge arc as the first one, they just put markings where it intersects. And that's it. So, because you just need that first arc for points of intersection.
Yeah.
To put your compass. How's our in-center looking? In-center. Looking good in-center. Unfortunately, I don't know if anybody heard my discussion with Julia there. There's really not a way to check this because I know it's equidistant from the sides, but that equidistant from the sides has to be the perpendicular distance. And so you would have to find the point on CB that is perpendicular to there, which is a whole new construction, and this is good enough. All right. So it's kind of hard to check. Can I do this? Probably not, because I got to find the actual point where it would. Not bad. Can I do this? Yeah. That's going to be the center of a circle you could draw inside instead of outside. Okay, in center. Any issues? Because now it's going to get a little tougher. Let's be honest. This scavenger hunt I'm putting you on, you look for the darn word perpendicular bisector. You look for angle bisector. Right, now it's going to get a little bit tougher about what construction could I use. All right, next up, centroid. Ready to talk to me? Centroid. Talk to me. What are your thoughts? Thoughts on the centroid, Riley?
The 1/2 it's a 2-to-1 ratio.
Okay, splits the median into 2-to-1. I kind of already gave away the other part here, but that's actually how we're going to look at it and check it at the end. How's it form though? It's already up here, but how do you form a centroid? Michael, how do you form a centroid?
3 medians.
Yes, 3 medians intersect. And unfortunately, as you look at those videos, not one of them is titled medians. But it's there. There is one of those videos that could help you. Which one? All right, let's dig a little deeper now. Talk to me about a median. What is a median? How could I draw a median in this triangle I just threw up here? Talk to me about what a median is so maybe I could start figuring out which video to watch here. Sophia, median? Perfect. And? Hits the one again? Because that's going to be the key. It's got to be drawn to the midpoint. Hey, look. Here's a little hint to where to go. If you guys can find me the midpoint of CB somehow using your compass, I'll just draw it in from A. If you can find me the midpoint of CA somehow using your compass, I'll draw it in from B. I just need to know how to find the midpoint. All right, there is no median construction, correct? But you do. How do you find the midpoint? What could I use there that could find the midpoint? What could I use in the videos there that finds the midpoint? You don't have to go far, Riley.
The perpendicular.
Guy, yeah. Hey, look. When you draw in a perpendicular bisector, where does it go through on each side? The midpoint. Correct. All right, so that's all I need here is the perpendicular bisector. But whoa, go ahead. Draw me the arcs, but do not draw in the bisector. Okay, get me the arcs done first. Okay, so take a side right now and do your perpendicular bisector arcs, but do not draw in the actual bisector yet. Here's why I don't want you to draw it in. Let me do it. Hey, is that a median? Did I just draw in a median? No, that doesn't come from a vertice. That's a perpendicular bisector. But I can at least line up my straight edge right now with it. I don't need to draw it in, but now you can locate the midpoint and put a point there. Okay, so line up your perpendicular bisector, and all you need from this is the midpoint of whatever side you're doing right now. So make a little mark of your midpoint, wherever that happens to be, and then draw your median in now. Okay, so mark your midpoint, draw in the median. Now, would I take off if you drew the perpendicular bisector in, then the median to the point? No, I just think the less lines, the better, right? The less lines, the better. So there's your first median right there. Medians go to midpoints. One more time on another side. One more time on another side, kids. How's everyone's centroid looking? One construction, 2 points of concurrency it'll give you. One construction, 2 points of concurrency it'll give you. Now, let me go back to Riley. First thing he said was splits the median in a ratio of 2 to 1. Unless I actually, measure this with a ruler and figure out that that is double that. But let's take a look. Look at vertice to centroid should be longer than centroid to midpoint. Looks pretty good to me. Okay, one is double the other, and here's the part that should always be doubled, is the vertice to the centroid. Looks pretty good to me. Now, if I had it the other way around, I did something wrong. Okay, but definitely looks like 2 to 1. If you really want confirmation, I guess you could take out your ruler, measure the distance, and see one's double the other. Any questions on centroid before we get to the final one? And it's the final one for a reason. I put it last. Woo! All right. The orthocenter. Talk to me. Orthocenter, what do you know about it? Orthocenter. Cam, orthocenter. Good job. Too bad there's no altitude video up there, huh? Also here, I'm not going to write it down. Look at the triangle I'm having you find the orthocenter for. Is it acute, obtuse, or right? Looks like it's an acute. So prediction, where would the orthocenter be located? Inside. Definitely going to be somewhere inside. So keep that in mind. Ooh, altitudes. I don't see an altitude video. Do you? No, me neither. Son of a gun. All right, so somebody's going to have to tell me about an altitude. So maybe one of the videos will help me. Altitudes, Maddie. What's the deal with an altitude?
It comes from one of the vertexes.
Yep, and?
And does it, does it form midpoint? No.
That's median.
Yeah.
Form something.
Right angle?
There you go. Yep. So that's what it does. Forms a right. It's got to be perpendicular to the opposite side. Perpendicular to the. Now, whoa. I've been having a lot of luck with my good old perpendicular bisector construction, and I can do two things with that. Would that help me here? And the answer is no. Here's why. Because it would not go through your vertice. It'd probably look something like that. Okay, it would not go through the vertice, unfortunately. So that one is not going to help. But there is one on there that will help. What's up, Riley?
Perpendicular through a point.
Perpendicular through a point. Now, as you watch that video, the point is actually on the line there. Versus ours, if I'm going to draw my altitude from C to BA, C is off the line. But it's the same construction. Take a look. Start watching the construction. We're going to do this one together. Start watching the perpendicular from the point. You'll notice, where does the compass point go? Where does the compass point go? On the point it needs to go through, which for us is our vertice. All right, so if I'm going to go from C to BA, my compass point goes on C. And then as you keep playing the video, you need to make an arc that intersects the opposite side and how many spots? How many spots? Twice. So open up your compass right now. Make an arc that intersects BA in 2 spots. You're going to have to play around with your compass here a little bit. I'm doing the same thing as the video is, except C's not on the line, but the same steps. Okay, we got points there. And now notice what's happening in the video. After you get the 2 points of intersection, you place your compass on each point and make two more arcs that intersect each other. And those last 2 arcs have to be the same opening of your compass. And then you can draw your altitude in. If you want to put a right angle symbol with it, you can. All right, let me just give a little warning before you do your second altitude. It may happen that when you put your compass point on a vertice and try to make it intersect the opposite side twice, you might only be able to hit it once. Okay, you might be able to hit it once. And if that is the case, simply take your straight edge and extend the side so you can make it intersect twice. I don't know if that'll happen to you. I'm not saying it will or won't, but if you're playing around with your compass and you're like, oh my, this is so frustrating, I can only make the arc intersect that side in 1 spot, just extend your side to make it intersect in 2 spots. All right, so go ahead and see if you can get a second altitude going to BC or CA, your call. And hopefully your ortho center is indeed inside your triangle. So if you can only make it intersect in 1 spot, okay, no big deal. Extend your side. I think I'm going to have to do that.
This is,
Mine's a little, yeah. Sure, your guys is a little higher
yeah,
than mine is.
yeah.
Yeah, I don't have a straight edge either. I'm just trying to line it up the best I can here. Well, that's probably why. Should have been up there. There you go. All right. I think I'm ready to stop talking and just stop talking and see what you guys can do on this last one on the Ortho Center. I guess we'll do a quick discussion. Anybody, what type of triangle is that? Obtuse, where's your outside the triangle, right? Should be outside the triangle. Okay, whatever you don't finish here is to finish tonight, but you should, I think you'd be able to finish it. If not, finish it up tonight. This is your only one, last one. If you cannot make it intersect, extend the side. Because whether you go from point A or C, your altitude's going to be outside. Point B, your altitude should be inside. If you can only make it intersect the opposite side in one spot, extend it.
I is B to a C.
Keep extending your altitude too. If you remember, you need them to intersect. Keep extending it. There's the one coming from A. There's the altitude coming from A on the outside of the triangle. Okay, finish that up for tonight, please. Stat construction.